Hey, good day, boys and girls of chemistry. We're going to continue on with naming different organic compounds. Last time we talked about the alkanes, which are structures that have the carbon and hydrogens. They can have other things attached, but the distinguishing feature of the alkanes is that they all have single bonds, right? Everything in here has a single bond. We learned how to name it with substituent groups, and we looked at ring structures, that kind of thing. These were all called aliphatic hydrocarbons that we've been looking at. Today we are going to continue by looking at ones with double bonds and triple bonds and how to name them. So hopefully after the video today you can name double bonds and triple bonds. Okay. So we're starting from question 25 with your homework package, your self-study package. Okay, so it says, so far you have worked with hydrocarbons containing only single bonds. These are known, right, as saturated hydrocarbons, right? Every possible bonding spot is filled. Okay, each carbon has 4 bonds and it's saturated with hydrogens. Okay. But it's also possible for double bonds to form between carbon atoms. For example, as long as carbon still has 4 bonds, it's okay. So a double bond counts as 2 bonds. So that's 1, 2, 3, 4, 5, 6, 7, 8. So carbon still is satisfied with its octet rule, and now because it's sharing electrons, it had 4 valence electrons, but it's formed 4 bonds. 1 double bond here, that's getting the extra 4 electrons it needs to complete its octet. So it's happy. Okay? Hydrocarbons containing carbon-carbon double bonds are called alkenes. Enes with an E. Alkenes. We looked at alkanes. These are alkenes. Alkenes possess 1 or more double bonds and are considered unsaturated hydrocarbons. That means that every possible bond is not filled with a hydrogen. Unsaturated hydrocarbons can incorporate additional hydrogen atoms and other atoms into their structure and are highly reactive. So when we look at chemical reactions involving organic molecules, a lot of them happen with alkenes, because what can happen is we can break this double bond and then attach something else to it. So that's why they're reactive, because potentially if we break this bond here and form a single bond, then we can attach something else to it. Okay, the same rules for naming alkanes, and it's been kind of underlined that, apply to alkenes. But instead of ane, the suffix is ene is used. For example, this is called propene, right? So again, we need to look at the parent chain, and we've got 3 carbons, so that root word is going to be prop for 3, but we notice that this one has a double bond in it, so it's not going to be ane like the last one. We're going to put ene on the end to show that it has a double bond in it. Okay, so this one says, name the following compounds. Remember that if it's not shown, that there are attached hydrogens here as well. You can draw that in if you want. Okay, so this has 2 carbons in it, and 2 carbons, the root is F, and then we want to show that it's got the double bond, so we put ene on the end, ethene. Okay, this is a ring structure. So that's going to have the term cyclo for the ring. And then we count the carbons, 1, 2, 3, 4, 5. 5 carbons is pent, cyclopent, and then we've got a double bond, so that's going to be ene, cyclopentene. Okay? If you don't know what those terms are from before, right? Meth, eth, prop, bute, pent, hex, hept, oct, non, dect. That should be your first stop. You really got to memorize those to use them properly. Okay. So, as you can imagine, that we've got, so this one, 1, 2, 3, 4, 5, so 5 carbons. The root name is going to be pent for 5, but we can notice that there are a couple different places where we could put the double bond. It could be here, could be here, could be here. If it's here or here, it's going to be the same. We'll just start numbering carbons. But if it's here, it's going to be different. So there are some different locations. So we need to communicate where the double bond is in the name. So where the double bond is, when we're numbering our carbons, it's going to get priority. To do this, find the longest carbon chain containing the double bond. That's important. Even if it's not the longest chain, it must contain the double bond. Okay? So that's important. Starting from the end closest to the double bond, count the carbons. Give the double bond the lowest possible number. So in some ways this becomes a little bit easier because for numbering, the double bond gets priority over any other attached groups. So it makes it a bit easier. So find the longest chain that gives the double bond the lowest possible number. The position of the double bond is designated by the lowest numbered carbon joined by the double bond. Write the number before the suffix "-ine". Okay? So this would mean that we want to give this the lowest possible number. So if we labeled it from left to right, it'd be 1, 2, 3, 4, 5. If we labeled it from left to right, it'd be 1, 2, 3, 4, 5. So we probably want to label it here. But what this means is that we indicate where the double bond starts on the lowest carbon. So you could say, well, do I consider it to be carbon 3 or carbon 2? We consider it to be carbon 2. Okay? So this is called pent, and then you see it's inside 2-ene. When it's straightforward, and you might see this on a test too, it's also possible to write it as 2-pentene, like this, where the 2 then indicates where the carbon is, but you can also write it inside, like this. Okay, so just be aware of this if something like this shows up on an exam, that this 2 is referring to the location of the double bond. So it says name the following compounds. So, okay, so we got 1, 2, 3, 4, 5, 6. I've got 6, so I know it's going to be hex for 6. It's a double bond, so it's an alkene. So I need to show where the location of that double bond is. So I want to give it the lowest possible number. So if I start counting this way, it'd be 1, 2, 3, 4. So it could be hex 4-ene, 5, 6. Or 1, 2, 3, 4, 5, 6. Start here, it's going to be 2. So I want the lowest possible number, so it's hex 2-ene. Okay. This one's been kind for you, and it's labeled it for you. So this has got 7 carbons. 7 is hept. Hept. And then it starts on carbon 3, so 3-ene. Okay, this one 1, 2, 3, 4, 5, 6, 7, 8. Oct. And then I'm going to need to give the bond the lowest possible number, so that would be on carbon number 3. I'll start labeling it this way. Carbon number 3. Okay, next, substituent groups. 4 substituent groups use the same rule with alkanes, except the longest chain must contain the carbon-carbon double bond, and it gets priority for the numbering. Okay, so in some ways this makes it a little bit easier now. So the longest chain must contain the double bond. So we could say 1, 2, 3, 4, 5, 6, like this. You could go 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6. Oh, wait a minute. 1, 2, 3, 4, 5, 6, 7, 8. They have must contain the double bond. So if we go this way, it's not going to contain the double bond. Okay? That's not a mistake. So the only way we can do it so that everything that contains the double bond is to do this L shape like they've done. That's correct. Okay? So the number of carbons in the parent chain, it says circle them, so that's 1, 2, 3, 4, 5, 6, 7, contains the double bond, 7. The parent name for this alkene is hept 2 ene, right? The double bonds on the second carbon. The two substituent groups are, so we've got a group here and a group here. So we've got a methyl group, 1 carbon methyl, and we got a 3 groups, that's a propyl group. So, and again, we need to, these ones go in alphabetical order. So they're going to go first. So the methyl group goes first. So we're going to indicate where it goes. 2 methyl. 3 propyl. Hept 2 ene. There's your complete name. 2 methyl, meaning is a methyl group attached to the second carbon. 3 propyl, is a propyl group attached to the third carbon. Hept, the longest chain, the parent chain, has 7 carbons. 2 means that ene means there's a double bond with on carbon number 2. If you really break it down step by step, you can see how this works. Okay, so more naming practice. Name them. Okay, the first one, they've been kind. So the first thing we need to do is find how long the longest chain that contains the double bond. So that gives us our parent chain. So they've been kind to label it. So 1, 2, 3, 4, 5. Because if we labeled it the other way, it would start on carbon 3. But we need the lowest bond, so we've got 5. So that's going to be pent 2 ene. And then we've got 2 attached methyl groups. So we've got a methyl group on 2, 4, 2 and 4. And there's 2 of the same, so we had to use the prefix di, methyl, pent 2 ene. So the full name of this is 2,4-dimethyl pent 2 ene. Okay. Ooh, they haven't labeled this one for us. So it's whatever we do has to contain the double bond. So we couldn't label it across this way because it wouldn't contain the double bond. So either we've got to do this kind of L shape like this or this. So this is 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6. So longest chain that contains the double bond goes like this. So it's hept, parent name. Now we just go to get it. So if I label it this way, 1, 2, 3, 4, 5, 6, 7, it will contain the double bond. And it will give the carbon that starts with the double bond the lowest possible number. Okay, because if I do it this way, then the carbon's going to have a higher number. All right, so that's hept 2 ene. Okay, and then that means I've got a methyl group attached there, and then I've got 2 carbons here, so that means I've got an ethyl group. We're going to label these in alphabetical order. So the ethyl group comes first, and it's on the 4th carbon. So this is 4-ethyl, 2-methyl, hept 2 ene. What about this one? So longest chain that has the carbon. So this is 1, 2, 3, 4, 5, 1, 2, that would not contain it. 1, 2, 3, 4, 5, that would contain it. I think we'll just go across like this. So this one, the root name is going to be pent for 5 carbons. If we label it across this way, then it gives carbon on 1, 2, 3, 4, 5. Carbon number 2, pent 2-ene. And then we've got 2 methyl groups and an ethyl. So we need to, the ethyl comes first. So this is, I'm going to try and write at the top, 3 ethyl, and then it's on 2 and 4, 2, 4 dimethyl pent-2-ene. It's a long name, but if you do it step by step. And then again, I think for myself, if I was writing this test, what I would do is I would try to sketch it out as I've done to show you here, where you do it piece by piece, but then maybe either erase it or copy it down below so it's neater. You want to do the work first to figure out how to name it. Okay, so we've got a ring structure here, so we know that the root name has got to have cyclo in there, cyclo. How many carbons? 1, 2, 3, 4, 5. So that's pent, cyclopent. And then they've labeled the carbons. So with a cyclic structure, then the double bond is probably going to be on the first carbon. You're going to start labeling it from there. That's where one, so it's just going to be pent-ene, meaning that the double bond is found on the first carbon. So that means on the third carbon, we have an attached methyl group. So this is 3-methyl cyclopentene. Okay, next, longest group. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It doesn't matter. I'm going to label it starting here. 1, 2, 3, 4, 5, 6. And since so it's 6, so it's going to be hex. And it's on the first carbon, so I don't really need to indicate that. So I can just say hexene. And then we've got an ethyl group on the fourth carbon, so it comes fourth, 4-ethyl, and then 4-methyl, methyl group, hexene. Okay, this one is monstrous. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, 10. That's probably going to be the longest. If I go like this, it's not going to contain the double bond. I guess the only other way I can do is like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the longest chain. It's going to have dec. So numbering it from this way would go 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4. So 4 is the best way to label this. 4-ene, dec 4-ene. Double bond is on the fourth carbon. I got 2 methyl groups. Let's see, this is 1, 2, 3, 4. So this is a butyl group. And this is 3, so this is a propyl group. So this is going to have a monstrous name. I hope I have enough space. So that we have to alphabetical order. So first, butyl. So this is 1, 2, 3, 4, 5. It's on the fifth carbon. 5 butyl. And then methyl comes next, and then it's 3,9 dimethyl. There's 2 of them. and then 1, 2, 3, 4, 5, 6, 7 propyl decphorene. There's the name of this monster. Okay, so this shows you can name these, and if you just look at the name at the end, it does look insane and very, how do you do it? But you have to break the problem down step by step by step. This is not a problem you can just start writing things down. Do it in a step-by-step fashion and you can get the answer. Okay. The next one, G. Let's find the longest chain containing the double-double bond. So 1, 2, 3, 4, 5, 6, 7, 8. I'm pretty sure that's going to be, so the root name of the parent chain is going to be oct. Looks like on the third carbon, we'll give it the lowest number, so oct3ene. And then, so that means I've got 2 attached methyl groups, and I've got an ethyl group that's attached to it as well. So ethyl comes first, and that's on the 4th carbon. So this is 4 ethyl, 2, 5 dimethyl oct3ene. So you'd probably want to write this again so it's nice and neat, but there you go. So 4 ethyl, 2, 5, and I guess there should be a hyphen in there too, dimethyl oct3ene. Okay. You need to pause and think about it at the end. Okay. So if we think, we'll have to get the models out to show you that this can happen, but so when we have an alkane, things around a single bond can kind of spin and twist and rotate very freely. But a double bond holds very tightly, so it restricts its ability for these carbons to kind of spin and twist, and for these hydrogens to spin and twist. So it very much sets where everything's going to be. So you get these things called isomers. Iso, the word iso is Greek for same. And the same kind of a monomer, a mer is like a building block, a building kind of molecule. So it means that they can be the same, almost the same, but kind of mirror images of each other. And there's different ways they can look. Okay. So it says here a double bond, here's your double bond, can restrict rotation. That means that these parts to twist around and spin around this carbon, and therefore is able to alter the geometry of the molecule. In but2ene below, the methyl substituent groups can be found on either side of the same double bond or on opposite sides of the same double bond. So this is on the same side, these ones are down below. See, this one has gone from up here down here. The prefixes cis and trans can be used to differentiate cis and trans geometrical isomers. So these are ones that almost look the same but are a little bit different and can have different kind of configurations. So cis means that they're on the same side. So this one is cis. We've got this up here, they're on the same spot. Or they could be down here. And the hydrogens could be up there, so it's on the same spot. Okay? These ones are on opposite sides. So this is known as trans. Okay? So the cis isomer of butene but2ene, cis, which the name then becomes cis but2ene, is represented by isomer number 1. This is cis. Okay, this becomes important when you want to draw it. And you'll need to be able to draw these things later on when we go through drawing examples. trans isomer of butene, trans-butene, is represented by isomer number 2 on opposite sides. Okay, name the following compounds. Not all of these are cis or trans. Personally, I have a hard time seeing things rotating in my head unless I'm building the structures out of the model, so I really don't like these too much. I think it's important that you know that these are here, especially for any kind of biological molecules that we might be studying in AP biology, or even maybe a little bit of work in AP chemistry. As far as like a test goes, I don't like these, so you can kind of guess the importance and the frequency which these kind of questions might show up on a test, because if I don't like them, I don't want to mark them. Okay, but let's go over these. Okay, so first of all, don't get confused. What do you notice about this molecule? Okay, the first thing you should see when you look at this molecule is that everything has a single bond. Okay, they're all single bonds. So are those alkenes that we've been looking at? No, this goes back to what we first looked at. This is an alkane. Okay, so it's going to have the ending ane. So that means we need to find the longest group. 1, 2, 3, 4. And actually, they've labeled it nicely for us. 6, and they've shown us the direction to label it too, so they've made it easy. So it's going to be hexane, because it's an alkane, hexane, all single bonds. Okay, now what do I have? I've got 1, 2, 3 methyl groups and 1 ethyl group. So ethyl, E comes before M, so we need to say it first. So that's on the 3rd carbon, so that's 3 ethyl. And then we got a 2, 4, 5, and then 3 is trimethyl hexane. 3 ethyl, 2, 4, 5, tri for 3 methyl, trimethyl hexane. Okay, next one. What's the first thing that you see with this next one, C? The first thing you should be looking for is, are there any double bonds, or even we'll look at later, triple bonds? And yes, I see a double bond right there. So we know this is an alkene. Okay, so it's going to have the ene ending. Okay, it's going to have ene, an alkene. Okay, they've been very kind to number everything for us. So it tells us we've got 9 carbons, so that's non. And then the bond's going to get the lowest number, so it's 2-ene, non-2-ene, like this. So that means that we've got 1 attached. This is 2 carbons, so that's an ethyl group, and so that's attached on carbon number 4. So this is 4 ethyl non-2-ene. Okay. D, what do you notice about D? I hope in your head you're screaming, there's a double bond. Well, that's right, double bond. So that tells us that we've got an ene. Ending. And 30. Okay, so then the next thing is the length of the carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be oct. I'm running in a space. Maybe I'll do it over here, oct. And then 1, 2, 3, 4, or 1, 2, 3, 4. It doesn't matter, it's the same either way. 4-ene. Okay, so that includes everything, but look at how it's set up. Maybe it's easier to see it if you flip it like this. So this part could be up here, and this part could be down here. So this is one where there could be some sort of rotation along the double bond. You see it, this carbon chain could go up where the hydrogen is, and this hydrogen could go down. So it does look like both of them are set up so that they're on opposite sides of the bond. So this would be a case where the answer, this would be called trans oct-4-ene, this one. Okay, this one should be easier to see it, okay? That there could be isomers of this one, okay? So, first of all, what do you see? Double bond. We've got an ene. I'm gonna write it up here. We have lots of space. Ene, okay? Lowest 1, 2, 3, 4. 1, 2, 3, 4 doesn't matter, so it's gonna be 4. And 1, 2, 3, 4, 5, 6, 7, 8. That's going to be oct. Oct-4-ene. And then I noticed that these are on the same side. It's kind of almost like a mirror image of each other. So this would be cis. This is cis oct-4-ene. Okay. Remember, Mr. Harrison doesn't like cis and trans because unless I'm really on the ball and thinking about it, then even I make mistakes with these ones, and I don't want to give you questions where I frequently make mistakes on them. So read into that what you will. Okay. We're going to do the last little part here because I don't think it's that hard, and we might as well combine it with this as well. So looked at the alkanes, all single bonds with alkanes, right? We've just looked at the alkenes. They have double bonds, so what's the next possible thing we could have for carbon? We could have 3 bonds, okay? Some unsaturated hydrocarbons contain carbon-carbon triple bonds. For example, like this. Okay, so it's got 2 carbons. We know it will have the root word eth with it. So we need to know the ending. Hydrocarbons containing at least 1 carbon-carbon triple bond are called alkynes. Alkynes with a Y this time. The rules for naming are the same as the alkenes and the alkynes, except that the ene ending or the ane ending is changed to Y and E. So this compound, parent chain, 2 carbons, eth, and it's going to be the same on either side. This will be ethine. Ethine. Okay? And then just like with the alkenes, we're going to have to say where we find the triple bond. Okay? So this one has 1, 2, 3, 4 carbons. So 4, it's going to have bute. And then we've got it on carbon 2, and it's the same on either side. So it's going to be bute, 2, ine. Remember, on a test, this could show up too, and it would be perfectly okay to say 2-butine, like that. Okay? Remember the chain has, so this is 1, 2, 3, 4, oh, they've labeled it for us. So it's on the first carbon. So this is going to, it's got 5 carbons, so this is pentyne, 5 carbons, triple bond, pentyne, and then I've got an attached ethyl group, so I've got 3 ethyl, 4 methyl, pentyne. C, they've been kind, and they've got 1, 2, 3, 4, 5, 6, 7. So this is going to be heptyne. And since the bond is on the first carbon, that just indicates that's where it is. Okay. Heptyne goes like this. So that means I've got a methyl group. So that's on the third carbon. That's 3 methyl heptyne. That's that one. Okay. D. 1, 2, 3, 4, 5, 6. So this is hex for 6. So on the second carbon, hex 2 ine. Okay, and then 1, 2, 3, 4 on the fourth carbon. We've got 4 methyl hex 2 ine. Okay, so just kind of the same as the other ones. Not a big deal. And there could be. Okay. I think I'm going to leave it there, and then we'll talk about the ring structures on another day. So make sure that you're giving yourself lots of practice with alkanes, alkenes, and alkynes. Alkanes, single bonds. Alkenes, double bonds. Alkynes, triple bonds. So if you look back at this, alkanes, all single bonds, these are double bonds, and these are all triple bonds. So just CC, this is CC like this, and this is CC like this. Okay? Next time we're going to talk about some benzene rings shortly, briefly, because we're not going to get into that too much. But then we're going to talk about what are called functional groups. We can get these other kinds of groups that are attached onto the carbon chains. So we don't always just have carbon and hydrogens. We can have oxygens and nitrogens and other things attached on there as well. And they have very specific names that indicate what's attached to them. It's different functional groups. So we'll talk about that next time. Okay? Have a good day.